Hi, this is Kyle with Icon Poly, and today we're going to show you how we process 3D files to print on our large scale format 3D printer. Now this is a fused filament printer, and that's the process we use. And I do want to warn you, it's running and the computer is right beside it, so it's going to be a little bit loud. I'll try to talk up, just listen closely please. So on with it, we're going to get to the computer and we're going to start processing a file. Okay, we're going to show you how we process 3D files, getting them ready to print on our large format 3D printer. I want to remind you again, it is a little bit noisy because we're sitting right beside the printer and it is running at the time. So the first thing we're going to do, and I've already done this, is we open up Netfabb. Netfabb is a program, and it's an Autodesk program now. It used to not be. It was an independent company, but Autodesk bought them, so you can get it through Autodesk. And our version, actually, we own this version. We owned it before it was an Autodesk. So this works good for us. It's got all the capabilities we need. We don't use it to the full capacity that it is. We only use it to process 3D files. So most of the files we do, or what we normally always do, is put them in the STL format, and they're all done in ZBrush, and then we put them in STL format out of ZBrush, and then we process them so they can fit on our machines and our 3D printers and stuff. So we're going to show you how we're doing that with the 3D printer. So we're going to do a prairie dog. This is a 4-foot prairie dog sculpture is what we're going to do. So all we do is we go up here to open, and we already have Netfabb Professional 5.2 is what we're using, and we're going to bring in our prairie dog scaled. So we're going to open that up, and you're going to see that it's importing. And we're just going to add the part. Okay, there we go. That's our prairie dog sculpture. And of course you can orientate it up here. We're not going to go through all the buttons because that's not really what this is about. It's about how we process. So we're going to orientate it, and if you look down over here in the right hand corner, it's going to give us our size. Now our size is 48 by 22.67 by 22.42, and this is in inches, not in millimeters. So since this is 48 inches tall, we can only print about 20 inches tall on our large format 3D printer. So we want to slice this thing. Now the first thing we need to do is we need to analyze it for overhangs, because on our 3D printer, on any 3D printer that uses a fused filament format, is what we do. We use a filament, and it fuses, so it builds it up from the bottom to the top. Any overhangs aren't supported, so there's a few ways that you can fix overhangs. So I'll give you an example. Up here, if we're printing this part, this mouth and this nose comes out here. In this instance, it's not enough of an overhang, but if that was overhang more, say like a dog's nose, then we would need to support that material, because when it's 3D printing, it has to be able to lay the material on top of something else. And if it goes out here and tries to 3D print out in the middle of nowhere, the material just goes out like spaghetti, and it doesn't lay on top anything. So the first thing we do is we analyze the model to see if there's any overhangs that are complete 90-degree overhangs, or the up angle is steep enough that the material won't lay on top of each other. So in this case, we knew we were going to 3D print this thing from the beginning. So in ZBrush, we kind of put it in a position that we could 3D print it without support material. I'm sure there's other people out there that just absolutely love support material. And when I mean support material, it's any material you have to print on the bed of something in order for it to lay an overhang onto. Support material is a love-hate relationship with us. If we have a problem with the print, it always begins in the support material. So we do what we can to eliminate using any support material when we're 3D printing. That's why we really like this Netfabb, and we like processing the files, because we can process these files down and cut them into pieces to eliminate any overhangs when we're 3D printing. And then at the end, we just glue the whole thing together and end up with a sculpture. This one's pretty simple. We're going to actually cut this in parts shorter than 18 inches. So our 3D printer will go up to about 20 inches, but we kind of just say, okay, 18 inches is good. We don't push the envelope. It doesn't really matter between the 18 and 20 on most of this stuff. So we have a 48-inch guy, so we're going to end up doing him in 3 different parts. The first thing we're going to do is we're going to make sure this is at the orientation that it needs to be. So we're going to put it at the origin, and it's already imported there. And what that's going to do is going to give us a baseline down here of 0. So then in Netfabb, we're going to go over here, and we are just going to simply right click on this set cut in Z, and we're going to click set cut in Z, and then come over here on the model, and we're just going to guess about where we want that 18-inch cut to be, and we're going to click on that model. Once we do that, we're going to go over here, and in the Z cuts axis, it's going to say 16.55. So we clicked on it, you know, it was close to 18 inches, but so we're just going to change that to 18, and it's going to move that line to the 18-inch mark from this bottom origin. So we're going to hit execute cut, and what that did is it put a fence through him. Now, since this is a 3D print, we want those as level as possible. Now in Netfabb, we can move this plane however we want. We can move it up and down, and that changes things. We can cut him at an angle. We can even rotate this thing around if we need to, like, get an edge not to hit something or something like that. So, but in this case, we're going to just cut it at the regular angle. So we're gonna, since I moved it around, I'm gonna hit cancel that cut. We're just gonna put it in there again because that's actually the quickest way to go about it. So right click, set cut in Z, click on the model. We got it at 17.63 inches. We're gonna change that to 18, and we're gonna hit execute cut. Now when we hit execute cut, it doesn't actually cut the model. All it does is put the plane in there. So you can see that's where we're gonna cut that STL model. And then we're going to go over here, and there's some options here. You have only selected parts, use plane boundary, stitch the parts. We always have that checked. We always use a plane boundary. Not always, but 95% of the time we do. Remove original parts. We don't like to remove the original parts because as soon as it's cut, if it removes the part and there's a mistake, then we can't go back and change that. So we don't have it remove the original parts. We triangulate the cuts, and we create a group. So we're going to select the only selected parts. Now it's not even necessary to do that in this case because we're only dealing with one part on the desktop here. So if we had multiple parts here, what that's going to do, and the plane is going to say the plane on every part. So it would actually extend this on out like this, and then if you just said, hey, select or cut only the selected part, it'd still only cut this part even though it might be going through another part. So again, I'm going to go ahead and redo that because I moved it. Set cut in Z, click, got it at 19, change that to 18, execute part, puts the plane through there, and then all we have to do is we're going to select only selected parts, and we're going to hit cut. That's going to process a little bit, and it depends on how big your wire mesh is and stuff, and of course your processing of your computer and stuff. So there it goes. It's made that cut. Now you can't see that cut, but what happens is it's separated that part. So if we click on that bottom part, it's going to show us that that is a different section. So we can pull that out, and we have an 18-inch portion of that prairie dog. It's all filled in and everything. It does a really nice job. So now that can be treated as its own individual part. Now we can print this part as its own piece. So I'm going to actually move it back to the origin, because it keeps that origin even when we put it into our other processing software or 3D print software. We don't use Netfabb for our 3D print software. We actually use Simplify 3D because we have an open sourced machine. So I'm going to move this out of the way just so you can see what's going on. And we see we have the bottom of this guy here. So then I'm just going to right click on that and hit export part, and I'm going to export it as a standard STL, because that's what all our software likes. And I've already done this, so we're going to go over here, and it's Prairie Dog Part 1, so we're just going to hit Prairie Dog Part 1. If I didn't have it in here, I'd just type Prairie Dog Part 1 in there, and I'd hit save. In this case, it's going to ask me that, because it already exists, do I want to overwrite it? And I'll just go ahead and hit yes. Now here what it's doing is cleaning up edges and stuff like that. So it gives you some stuff. So there's some manifold edges on here, and it's going to want to clean those up before it exports them. In a 3D print, a lot of times that matters. If we're doing a 3D milling, it really doesn't matter, but we're going to do a 3D print, so we're going to hit optimize, and it's going to fix all those before we export it, and then we'll hit export. So there we go, and that part is actually exported out, and it would be ready to put into Simplify 3D. So we're going to go ahead and cut him again. So what we want to do is we want to always make sure that this flat spot, or the bottom of the sculpture, is at the origin. So we're going to take that and we're going to translate that to the origin, and there you go, you see it put it at the origin. We're going to just do the same thing. We're going to do a set cut in Z. We're going to right click on there, and we're going to left click on set cut in Z and come over here and click on the model. So we want to do an 18-inch piece again. We know we can go that high, and we're going to hit execute cut, and it's going to come in and it's going to like cut that much and just leave his head there. So again, and this is a good example like I was showing you before. Now we have multiple parts on here, so I'm going to click on this and move it into here. Now if I over here in this setting, you notice the plane goes through multiple parts because it treats the whole desktop as a part, so even though there's multiples here. So I'm going to click on this guy, and now when I click on only the selected parts, it will only cut this part. It won't actually cut through that part, even though the plane goes through there. Another thing you can do if it makes you nervous is you can just pull that plane in and only deal with that one piece. So then we hit cut here, and once again it's processing that, and the plane will disappear when it's done. We click on here, we see that his head's separate from his body. This is our second part. We know it's already at the origin, but we're going to make sure it stays there. And we do that because when we export this and then put it into our Simplify 3D program, it finds that origin as well. And if anybody knows anything about 3D printing, if your piece isn't flat on the bed, it's just going to create a mess when you start a 3D print. So we always put the origin here, and then that way we know it's going to follow all the way through. So then we're going to just export that part as an STL again, and that's going to be Prairie Dog 2 or PD2. It's already in there. I've already done this, and we're going to hit save, and it wants to know if we're going to overwrite. Now, of course, this wouldn't come up if we were putting it in for the first time. And we're going to hit yes. And in this case, there was no manifold edges, so it was a clean piece, so it didn't come up to fix anything, and it just exported the part. So now I can take that over there, and I can bring this guy to the origin. And we're not going to cut him because he's only 12 inches high now. So this piece is going to be 12 inches high, which is under the 18 that we like for maximum. And so all we really have to do here is export that guy out. So we're going to export that part as an STL, and We're going to put it as the PD3, Prairie Dog Part 3, and save that. So there we go. That's really how we process a file and it's just kind of a simplified way we process a file. In this case, we didn't have any overhangs or anything like that that we had to worry about. These are all going to print fine with no support material. And now we've exported them all out so we can go to Simplify 3D. So what we're going to do is we are going to close this. Now you can save this if you want. You can go up to Project and save this as a project, which means it'd keep the project, so it keeps them all three there. We've saved the files independently, so I'm not even going to worry about saving this as a project. I don't need to worry about this as a project anymore. So we're just going to close out, and we're going to not save anything. So now that we've done that, we're going to bring up our Simplify 3D program. Now here's our Simplify 3D, and I already have a factory setting which works good with our printer loaded up. And so all we have to do now is we just have to import the parts from the Prairie Dog. And I'll find it here. I wasn't quite ready, but there's the Prairie Dog folder right there. So the first part we cut, we're going to then just simply open it up. Now what it did is, this is all in millimeters, and it defaults to that. So it come in very small. So what we're going to do, and we know it's too small, so we want to scale inches to millimeters. And there we go. So that's our Prairie Dog rump or butt or bottom or whatever you want to call it. We can flip it over. We can see this is flat onto the surface of the 3D print bed. And it's basically ready to go. Now from this, this is a fairly good piece, so I'm actually not going to process this one because it'll take a few minutes, and I really don't want to do that, I guess. So I'm going to remove that piece, and I'm going to go back and I'm going to grab the head. And we're going to open that up. Once again, you saw it, put it in little. All you have to do is go up here and Simplify 3D and scale inches to millimeters. Again, since we put that at the plane origin, when we flip this over, you can see that this is flat on the plane of the 3D printer bed. Like I mentioned before, this is a large 3D printer bed. It's about 40 inches by 40 inches by about 20 inches tall is what our capacity is. This works even on small stuff. It's just that the Simplify 3D has it programmed in here for our large scale 3D printer. So there's the head, and then you would go in here, and I'm not going to go through all this because I'm not doing a tutorial on Simplify 3D, but these are all our settings and everything. And so those are all in there, and they're a factory file that I picked to use for this. And we're just going to hit prepare to print, and it's going to do all the slicing and everything that it does to slice the layers for the 3D print. Now we're going to print this thing with a 0.6 millimeter nozzle, so our layer slices are about 0.3 millimeters. It turned blue here, and then you can simulating that 3D print. Now I always like to do this. I'm going to hit pause. I always like to do this and come back, because sometimes in these STL files you'll get a little weird thing going on. So I want to see that when it lays this first layer down, that it's laying that layer down perfectly. If you see it like, that first layer is supposed to be the shape of the head, and it's got a line here, that means that thing's not sitting on the plane, and your 3D print's going to fail. So you need to have it sitting flat on the plane of the 3D printer. And then we'll hit play, and it'll just simulate that through how the 3D printer is going to print that. And as they're doing it, we'll just go up here and look in this left-hand corner. And the build time on that is going to be 19 hours, 19 minutes. We're going to use 269,814.6 millimeters of filament. and it's going to weigh 4.74 pounds when it's done, and it's going to cost us $53.79 in material. Those are all pre-programmed in here, just for some of our information. This stuff down here we don't really pay much attention to. It's the time that we pay attention to, so we can schedule a 3D printer to start again when this one is done. So you can see the process. It's just going through and it's building this this head of this prairie dog, and you can kind of see that it took care of any undercuts or any overhangs that there might have been. Just fine. It's going to print just fine. So once that's done, all we do is simply hit save toolpath to disk, and we save it to a we can, if your computer is hooked to your 3D printer, you can send it right to the 3D printer. We do not do that. We actually send it to an SD card and then manually take it to the 3D printer. And for various reasons, we just don't. We want them to be standalones. It just causes less of communication errors and all that stuff. So since the 3D printer sits right here beside this, that's kind of how we do it. And we would hit save and put it on an SD card, and then the SD card we would take and transfer to the 3D printer. Thanks for watching, and we'll move on to the next segment. Okay, so here we are. This is our 4-foot prairie dog. You've seen us process the 3D file with using Netfabb and Simplified 3D. You saw it printing on the large format 3D printer, and then you saw it in black when it came off the printer because we were using black filament. Now he's in white, and the white is simply a primer on there because we're getting it ready for the next step to surface coat the piece to get it ready for a mold. Now, if you subscribe to our channel, you'll get a notification because we're going to try to do another video on surfacing this and getting it ready for a mold. So please like it, smash the like button, and subscribe to our channel so you can watch this process all the way through.